Hi guys, this is Diwakar back with another new cool video, and in this video we are going to make sensor controlled robot. So without wasting any more of the time, let's get started. First objective which we went through was implementing this idea. Literally we had zero idea how to implement this. Just like you thinking ये video में क्या करने वाला है. Then goes the second thing कि कुछ तो करना है. So what we decided to do is take out the pen and paper and list out the hardware and software components which are required to make this. So after discussing for us, we decided to go with our omnidirectional car which has two motors at the back and an omnidirectional wheel at the front, so that it would be easy to control the car by taking the full control over the rear two motors, by which we can easily turn left or right. Yes, you are right, it has only 3 wheels in total. Robot बुलाने से थोड़ा aesthetic लग रहा था, so क्या मतलब 3 wheels होने से auto बुलाना होगा? At first we thought to use microprocessor, that is Raspberry Pi, but पैसे. So we decided to go with Arduino Nano, हमारा सस्ता सुंदर microcontroller. But this has a problem. We need to connect this microcontroller to PC all the time. And the next objective which we face is to get the long data cable. But sadly ये microcontroller को type support नहीं है.
blue color ना मेरा मतलब
Color filtration చూడు.
guys blue film
But at this point of time we were unstoppable and we took all the risks and moved ahead. So our hardware part was completely ready and we were on to the software part. Firstly, we required an application which uses the phone sensor to predict the direction of the car, and the sensor which we use is accelerometer sensor which is present in your smartphone. And the direction must be informed to the PC to which the microcontroller is connected. So for that we would be using Google Firebase as it offers free 5 GB at first. The plan was simple. An app which uses an accelerometer sensor of the phone and gives the direction in which to move, and that direction is to be stored in the Firebase database, and then that has to be retrieved to our PC to which the microcontroller is connected. But the plan wasn't that simple as it looked like. We wanted to complete this project in 2 days and day 1 is over. So we decided to make this application using MIT App Inventor. We use the sensors value X, Y, Z for the direction of the car in which we wanted to move, and program it using the blocks, as it takes lots of time to make an application using Android Studio and we are running out of time. Later we connected the Google Firebase to our application and stored the direction value into the Firebase. Now coming to the final part, retrieving the data from the Firebase to the PC and program the microcontroller for our project. Firebase offers multiple programming languages to retrieve the data from Firebase to PC. We chose Python in our case, as I've learned Python few months ago thanks to Treasure. So we downloaded the .json file and connected our program with the Firebase and successfully retrieved the data. But we didn't have any idea how to program the Arduino Nano for our car. So after doing some research, we got to know about some libraries for the Arduino Nano, and we also got to know about the working of the car's motor. So the car's motor actually works like an XOR gate. We had 2 pins for each motor, and for motor to rotate, either one pin must be high and another must be low. So if it is 0 and 1, the car moves in forward direction, and if it is 1 and 0, it moves in backward direction, that is the opposite direction to the first case. So we understood that we need to use digital pins for this. But what about left and right? As our car has an omnidirectional front wheel, so we need to use the rear motors to change the direction. So if you want to move your car to left, the left motor must be in stop state and right motor must be moving forward, and if you want to take right, then right motor must be in stop state and the left motor must be moving in forward direction. Now we have imported libraries like Perfemata for the microcontroller, Firebase DB for retrieving the data from Firebase to our PC. So we will be sending the output signals to our microcontroller. So we will be using D3 and D4 for the left motor and D9 and D10 for the right motor, and this completely depends on you which pins you want to choose. But they must be digital pins. So we have successfully written the code and we were ready to implement it. Before implementing it, we checked whether all the things are working fine. So we installed this application, checked whether it's working perfectly or not. Cross-checked whether the data sent from the mobile and retrieved from the PC are the same. And went through our program for any errors, and we find 0 errors and we were ready to implement it.
Okay, Shabad, on the count of 3, 2, 1.
Sadly, nothing happened, no change, everything was the same. The wheels weren't rotating.
It's not working. We'll look into the problem again.
Once again, we checked everything to figure out where we went wrong. And lastly, we found that
You haven't connected the power supply. Silly thing. How will power? Okay, now we'll connect.
so we gave the power supply to the car and we connected the ground of the car to the ground of the microcontroller.
So this is the positive terminal which must be inserted inside this, and this is a negative terminal which we should wrap around it, and we'll use sellotape. So Shripad, one of our good friend, our team member, XCR, so is going to help us in making our robot.
And then turn on the switch again, hit on the run button,
Database.
and it was working perfectly.
It's working, guys. It's working. Remote control. Try to move the trapper. Wheel పోయింది మా అంత ఫాస్ట్ తిప్పేసి.
We had an issue. The motors were rotating so fast that we couldn't control its speed and eventually the pins were getting damaged. So all we had to do is control the speed of the car. Luckily we had some time to spare and we thought to manually control the speed of the car. For that we need to use analog pins, as analog values vary from 0 to 1 whereas digital has only 0 and 1 values. We created a new speed component in our app and the speed values are being sent to the database and being retrieved to the PC and we rewrite the code. So the speed varied from 0.1 to 1, 0.1 the least and 1 for the max speed. But this time we also need to change the pins from digital pins to analog pins. So we did some research on that and we got to know that the analog output pins are the same of digital pins, that are D3, D5, D9, D10, D13. But this time we need to change the digital pins to analog output pins. So for the left motor we were changing the pins from D3, D4 to D3 and D5 and the right ones remains the same, as these pins are analog output pins as well as digital pins. So that's how we control the speed of the car and successfully finish the project on time.
Hey, drifter.
Then guys, successfully we have completed.
So in case we want to do this, I'll be sharing some links in the description box below. You can refer that and create your own IoT project, just like home automation, controlling the lights using your voice, etc. Also do comment your views on this kind of videos, whether to make this kind of videos. Also show your love and support by liking this video, share this video with your techie friends. Lastly, subscribe to the channel and click that bell icon and help us to cross 4K subscribers. So that's me, KVDR, signing off, and I'll meet you in the next one.
Break. ఇప్పుడు పార్టీ దివా పార్టీ
సార్
మరి